Circuitry by Rupin, Iyer, and Diego Salazar.
Electronic circuits. Electronic circuits are composed of electronic components such as resistors, switches, and LEDs, in which they are interconnected through wiring that acts as a medium through which electrons can flow, known as electricity.
For example, this circuit includes a switch to dictate when electricity can flow and a resistor to limit the flow of electricity to the LED. So here we have the battery, we have a switch, we have a resistor, we have an LED on which it's placed on a breadboard, which is this.
There are two types of circuits, series and parallel. Series circuits have only one path for electricity to flow. If one component is turned off, the entire circuit stops flowing electricity, and they're generally less useful for everyday uses. On the other hand, parallel circuits have multiple paths for electricity to flow, and they can continue to function even if a component is turned off or stops working. Generally, they are more useful for everyday uses, for Christmas lights, wall power, and anything that uses electricity.
A visual aid, but with snap circuits. So here we have a series circuit, here we have a parallel circuit, which in this case, this series circuit permits electricity to flow in one direction, while this parallel circuit allows it to flow in more than one direction.
Resistors. Resistors are electronic components that limit the flow of electricity or cause resistance. Measured in ohms, resistance is the value R used in the Ohm's law formula. V equals IR. V being voltage and I being current. To calculate the voltage, current, and resistance. All resistors come with colored rings on them to show the resistance value. Each color and position has a certain value, having all of them added up to the total resistance.
Okay, here we have the resistance chart. This chart can actually be used additionally to find the approximate resistance of a particular resistor based on the colors of its band. So here for each column, we have the color column, we have the value column, the multiplier column, and the tolerance column. So for example, we have this resistor right here. The first color of the band of the resistor looking from left to right is brown. So we would look at the value. It's 1. So here's 1. Then the next color is green. So we would look at green. Here we have 5 for value. Then the third band is actually the multiplier. So when we look at the third one, it's 1, 2, 3. That's the times 10 to the second power, which is 100. So then the gold band is the tolerance band. So in this case, it's plus or minus 5%, as shown here. So 15 times 100, when you take these two values, times 100 equals 1500 ohms, plus or minus 5% tolerance.
So now it's time to construct a circuit. So here we have a resistor that goes here, so there, and then we can take the battery that would go down here. We could have the LED, which can go over here, and a push button switch that can go over here. So once all of these are in place, electricity will flow from negative to positive from this way here through the switch. Once you press the switch down, it'll flow electricity. It'll go through the resistor, lowering the current of through the circuit. It'll go through here, and it'll light up the LED and come back to the battery, and then continue the flow.
Thanks for watching, guys.